Now I want to show you a caveat that is mentioned in your textbook on page 102, if you want to look at it, but I'm just going to show you it. This is a situation where if you apply the usual approach and make your usual guesses, things don't work. And then I want to show you how to fix it and get things to work. So here's a second order linear non-homogeneous, due to this, differential equation. And let me apply the usual method of undetermined coefficients and see what goes wrong. So the first thing you might try to do is get a particular solution. So I'm going to follow this procedure that I laid out here. First, find a particular solution to the non-homogeneous differential equation. So let's call this L. Sorry. So then the differential equation can be written as L x equals e to the 4t. This is the differential equation. Okay, so what might I put in to try to get e to the 4t? So I can fiddle with it and think about what kinds of things should work. But yeah, by the way, here's the homework problem where I'm sort of getting the inspiration for this one. Which, by the way, sounds lazy, but it's not, because I made the homework problems. Okay, so I go here and I look at my table. What's the form of my source function? My source function is e to the 4t, so it's like something 1 times e to the 4t, right? So my beta here is 4, my alpha is 1. So I'm going to guess unknown coefficient a times e to the 4t. Okay, so let's see what happens when I put in a e to the 4t. Or really, yeah, let's just try that, a e to the 4t. What do I get? So I'm going to get a times what happens when I put in e to the 4t. And what does happen when I put in e to the 4t? I get whatever is the second derivative of e to the 4t, minus 4 times the first derivative. Just like that. But look what's going to happen. This is 16 e to the 4t. This is 4 times 4 e to the 4t, so it's also 16 e to the 4t. Oh no. We got 0. Oh no. So do you see why this is a disaster? The whole point of this approach, the whole idea is try to find a, try to choose the undetermined coefficient a, so that when you plug in this into L, what comes out is what you want, e to the 4t. So the question is, what choice of a, capital A, makes it so that this, which is this, equals e to the 4t, which is what we want to get out? The answer is no choice of a will do that, right? Because no matter what choice of a you choose, you're going to get 0. This is a problem. What's actually the problem? What's the source of the problem? Is that it seems L kills e to the 4t. In other words, e to the 4t is a solution to the homogeneous differential equation, the homogeneous version of this differential equation. So here's the source of the problem. E to the 4t is a solution to L x equals 0, the homogeneous version of this. That is the problem. To say e to the 4t is a solution to this is just a fancy way of saying L of e to the 4t is 0. That's what we're observing, right? So no capital A that you multiply by e to the 4t is going to stop that from coming out as 0, because L is linear. So this is a problem. So what do we do? The solution is multiply your guess by t. And that should work. Maybe it should work. If it doesn't work, then apply the solution again and multiply by t again, and so on and so on. But hopefully multiplying by t once works here. So now let's try guessing, instead of e to the 4t, how about te to the 4t? And then let's see if we can multiply by an a to get the thing that we want. So then we have a L te to the 4t. So that's a, and I'm getting tired of calculating this stuff, so let's just let me just call my guess here te to the 4t. So this is my guess, but without the capital A. And then let me just quickly compute what L does. So remember, L is, where did I write it? L is this, right? Take two derivatives with respect to t minus 4 times one derivative with respect to t. So two derivatives with respect to t minus 4 times one derivative with respect to t. And I get this stuff, which I can just simplify. Okay, 4e to the 4t. Great. 4e to the 4t. And look at that. I did not get 0. So that's awesome. I did not get 0. And you know what's also awesome is you might have thought that when I put in te to the 4t that I'm going to get a combination of some stuff with e to the 4t and some stuff with te to the 4t. But I didn't. I got just e to the 4t with some constants in front. That's great because I want to get something times e to the 4t. So that's pretty interesting, right? Like, back when we were doing this problem back here with the te to the 3t here, when we actually put in, sorry, where did it go? Here. When we actually went and put in te to the 3t into our left-hand side for x, what did we get? Not just something with e to the 3t, but a combination, e to the 3t and te to the 3t. But look what happened here. We put this in, and we only got this. This will actually happen every time you have this problem. This will happen every time you have this problem. And I will put some bonus content at the end of this video where I show you why this would happen every time you have this problem. So that will be optional. But you can believe that it will happen every time, and that's great. That we want, so this is the wanted equality, we want this to equal e to the 4t. We want it to equal e to the 4t. And so what should we do? We should have 4a equals 1, right? So a equals 1/4. And there is our particular solution. So what I was showing there is how to do this red step here in the general setup. Okay, and now here's the promised bonus content. So this is totally optional. You can end the video now and go to the next video. But if you're interested, why does this always work? This multiply your guess by t. So let's suppose you have this problem. So say you have your differential equation, L of x of t equals f of t. F of t is the source function or the forcing function or whatever you want to call it, is the right-hand side. And it's not 0, so non-homogeneous. And you're trying to find a particular solution. And say you have a good guess which is g of t. Let's call it g of t. So maybe your original differential equation has like e to the 4t out here, and you have a good guess, which is e to the 4t, like unknown coefficient, capital A times e to the 4t. Or maybe out here you have sine t, then you have a good guess, which is sine t, and another good guess, which is cosine t, something like that. So let's focus on one good guess at a time. So let's say you have a good guess, g of t. So by good guess, I mean like the guesses suggested in this table here. And let's suppose you run into this problem that I was mentioning. Suppose you have this problem that your guess, your good guess, your initially good guess that you thought was good, g of t, is actually a solution to the homogeneous version of this. So you actually get 0 when you put in g of t. This is like our problem here, where e to the 4t was bad. Then the caveat suggests that multiplying by t times your original good guess will be a good guess. So why is this a good guess? Well, let's say L, let's be pretty general. So let's say L is just any one of these second order constant coefficient left-hand sides. So something like this. Then let's apply L to this product, t g of t. And we're assuming that we started in a situation where we have this problem, that L kills g. Then when you apply L to this product, you get a times the second derivative of this, which is the first derivative of this. So let me apply the product rule to get the first derivative, plus b times, again, I'll apply the product rule to get the derivative of this, plus c times this, so t g of t. Okay, so here I'll put the derivative of this by the product rule. That's g of t plus t g prime of t. And here also g of t plus t g prime of t. So all I've done for this term is I've only applied one of the derivatives, and I'm leaving the other derivative there so I can give myself a chance to stare at it and think about what it should be. So this should be, let's see, g prime of t plus, now I have to apply the product rule to this. So I get g prime of t plus t g prime prime of t plus, and then I can copy this junk here. Okay. Now combine some terms. So I've got some stuff that has g prime and some stuff that has t g prime. Or maybe a better way to put this is there's some stuff that's multiplied by an overall factor of t and some stuff that's not. So here's the stuff that is multiplied by an overall factor of t. We've got a g prime prime, b g prime, c g. That's all stuff that's multiplied by an overall factor of t. And then what's not is I've got a, and then together these are 2g prime. So 2a g prime t. And then here I've got b g of t. And that's it. And look at this. This is L applied to g of t, right? And we're assuming that we're in a situation where we ran into this problem, that L of g is 0. So this is actually 0. So look what we got. 2a g prime of t plus b g of t. This is really good. So, okay, I mean, it could be that this is also 0, in which case you would have to iterate the procedure and continue multiplying by t's, like try t squared, g of t, and so on, until things work out. But assuming you're not so unlucky that this is also 0, then this is really good because you have found that that when you apply L to this thing, so G was your original good guess, right? Excuse me. G was your original good guess. When you apply L to this thing, you get a linear combination of G and the derivative of G. That's exactly the kind of thing you want when you're using the method of undetermined coefficients. Like back when we were working on, where'd it go? This one, we were relying on the fact that applying L to this gives us a linear combination of it and its derivatives. We just wanted not to get the zero linear combination out, right? We don't want to get zero coefficients. So getting out this and its derivatives, linear combination, that's good. When I was discussing what happens when you have sine here, then yeah, the reason this stuff works is that when you apply L to sine 5t, cosine 5t, you get a linear combination of these functions and their derivatives. So the reason this stuff worked is that because of the problem that you started out with here, multiplying by t put you in a position where normally you wouldn't want to take your good guess and multiply by t, right? Because you get all this extra junk. But because you had this problem that your good guess happens to be one of the fundamental solutions, because of that, this junk does not come up, and you have parts that are good that help you proceed with the problem. Okay, so I hope this sort of suggests to you or helps show you why what happened here when we multiplied our guess by t and got just this without some annoying other t e to the 4t stuff. What happened here is something that happens every time.